Anything that has volume and mass. Matter. Matter is anything that takes up space and has weight. Imagine trying to fit all your groceries into a single small shopping bag. Just like how each grocery item takes up space and adds weight to the bag, matter is anything that occupies space and has mass. The groceries represent different types of matter, each with its volume, space it takes up in the bag, and mass, how heavy it makes the bag, illustrating how matter is essentially everything that has volume and mass. The amount of matter in an object, mass. Mass is how much stuff or matter is inside an object, determining how heavy it feels. Imagine you're packing a suitcase for a vacation, trying to decide how much you can fit inside. Just like you assess the contents of your suitcase to determine if it's over the airline's weight limit, mass measures the amount of matter within an object. The weight of your packed suitcase represents its mass. Every item you add is like adding more matter, increasing the suitcase's mass, just as each particle contributes to an object's total mass. The amount of space an object takes up, volume. Volume is the measure of how much space an object occupies. Imagine trying to fit all your groceries into a single shopping bag at the checkout line. This challenge is similar to understanding volume, where you need to figure out how much space all your items will take up inside the bag. Just like how you must consider the size and shape of each grocery item to see if they fit together in the bag without overflowing, volume measures how much space an object occupies, determining whether everything can be contained within a limited space. An object's mass per unit volume. Density. Density is how much stuff is packed into a certain amount of space. Imagine trying to pack a suitcase for a week-long vacation, but it just won't close because it's too full. This is similar to the concept of density, where you're essentially trying to fit a certain mass of clothes within the limited volume of your suitcase. Just like how the suitcase's capacity is determined by how much you can pack inside it without exceeding its physical limits, an object's density is determined by how much mass it contains within a given space. The state of matter with definite shape and volume solid. In simple terms, a solid is a material where the particles are packed tightly together, keeping a fixed shape and volume. Imagine trying to fit a large, bulky sofa through a narrow doorway when moving into a new apartment. Just like the sofa maintains its distinct shape and size, regardless of how you try to maneuver it, a solid maintains its definite shape and volume, irrespective of the space it occupies. In this analogy, the sofa represents a solid, with its unchanging dimensions, symbolizing the fixed shape and volume characteristic of solid matter, while the doorway represents the space around it that does not alter the sofa's inherent properties. A state of matter that has definite volume but no definite shape. Liquid. Liquids flow and take the shape of their container while maintaining a fixed volume. Imagine trying to fit a pile of clothes into a suitcase. You can squish and mold them to fit the space available. Just like those clothes, a liquid conforms to the shape of its container, filling up the space available without altering its volume. The connection is clear. Both the pile of clothes and a liquid have a fixed amount of stuff, volume, that can be reshaped to fit into different spaces, but they don't maintain a specific shape on their own. A state of matter that has no fixed shape or volume. Gas. Gas is a state of matter where molecules move freely and spread out to fill any container. Imagine trying to fit a pile of clothes into a suitcase that's too small, causing you to constantly rearrange them to make everything fit. Just like the clothes that spread out to fill the available space when the suitcase is opened, a gas expands to fill the shape and volume of its container. The way clothes adapt to whatever space is available is similar to how gas molecules move freely and spread out, having no fixed shape or volume, adapting to the container they're in. A combination of substances that keep their individual properties. Mixture. In science, a mixture is when different substances are combined, but each maintains its own properties. Imagine trying to organize a group of friends for a potluck dinner, where each person brings their own dish. Just like your friends each bring a unique dish to the table while maintaining their individual flavors, a mixture is a combination of substances that each retain their own properties. In this analogy, each friend represents a different substance, and their dishes are akin to the parts of a mixture, coming together to form a complete meal while still holding on to their unique tastes and characteristics. A mixture of evenly distributed substances. Solution. In science, a solution is a homogeneous mixture where one substance is completely dissolved in another. Imagine trying to bake a cake, but all the sugar is clumped in one corner of the batter, while the flour is in another. Just like how an uneven cake batter results in a lopsided and unappetizing cake, a mixture of evenly distributed substances ensures a consistent and desirable outcome. In both cases, whether you're baking a cake or creating a scientific mixture, the goal is to achieve uniformity so that every part of the mixture contributes equally to the desired result, ensuring that each bite of cake or each sample of the mixture has the same properties. A measure of how much solute will dissolve in a solvent. Solubility. Solubility is how easily a substance can dissolve in a liquid to form a solution. Imagine trying to fit all your clothes into a suitcase for a trip. Just like there's a limit to how many clothes you can pack before the suitcase won't zip, solubility is the limit to how much solute can dissolve in a solvent. In this analogy, the clothes represent the solute, the suitcase is the solvent, and the space inside the suitcase is the capacity for solubility. Once the suitcase is full, no more clothes can be packed. Just like no more solute can dissolve once the solvent reaches its solubility limit. The smallest particle of an element, atom. An atom is the basic unit of matter that makes up everything around us. Imagine trying to fix a jigsaw puzzle when you're missing just one tiny piece. Just like that missing piece is crucial to completing the entire picture, an atom is the tiniest part that makes up an element, essential for its identity. Each piece in a puzzle is unique and fits into a specific place, just as each type of atom has unique properties that define the element it composes. Without that one piece, or atom, the whole structure can't be complete or function properly. A substance made of one type of atom that cannot be broken down chemically. An element is a basic building block of matter with unique properties. Imagine you have a jigsaw puzzle where every piece is exactly the same, making it impossible to break down into more basic parts. This is similar to an element, which is a substance made of one type of atom that cannot be broken down chemically into simpler substances. Just like the puzzle pieces that are all identical and form a complete image on their own, an element consists entirely of one kind of atom, which defines its unique properties and cannot be reduced further. A change in size, shape, or state, but not in identity. Physical change. In science, a physical change is when the form of matter is altered, but its substance remains the same. Imagine trying to fit all your groceries into a single paper bag, but realizing you need to rearrange them to make everything fit. This is similar to a physical change, where the items, like ice melting or clay being molded, might change form or arrangement, but remain the same at their core. Just as the groceries are still the same groceries no matter how you organize them, A physical change involves altering the size, shape, or state of a substance without changing its identity or composition. A change that produces a new substance. Chemical change. A chemical change happens when substances combine or break apart to form new substances with different properties. Imagine you're baking a cake, and once it's in the oven, there's no way to return it to its original ingredients like flour, eggs, and sugar. This is similar to a chemical change, where substances interact to create a completely new substance, much like how baking transforms your ingredients into a cake. Just as you can't extract raw eggs or flour from a finished cake, a chemical change is irreversible and results in the formation of a new substance, highlighting how the process fundamentally alters the original materials. The process where substances change into different substances through the breaking of chemical bonds. Chemical reaction. A chemical reaction is when substances mix and transform into new substances. Imagine trying to rearrange a cluttered room into a more functional living space. This is similar to a chemical reaction, where substances transform by breaking and forming new bonds. Just like you move furniture around by disassembling and reassembling it in different ways to create a new setup, chemical reactions involve breaking old chemical bonds and forming new ones to create different substances. A physical change of matter between solid, liquid, and gas. Change of state. It is when matter changes from one form to another, like ice melting into water. Have you ever tried to decide what clothes to wear when the weather keeps changing unexpectedly? This is similar to how matter changes between solid, liquid, and gas, adapting to different conditions, just like you adapt your wardrobe to the weather. Just as you might switch from a coat to a t-shirt as the temperature rises, matter transitions from solid to liquid to gas as energy heat is added, with each state being like a different outfit suitable for the prevailing conditions. The substance made when atoms from two or more elements combine chemically. Compound. A compound is a substance formed when different types of atoms bond together, like water being made of hydrogen and oxygen. Imagine trying to bake a cake with ingredients from your pantry. Just as flour, sugar, eggs, and butter combine to create something new and delicious when baked together, atoms from different elements combine to form a compound. In both scenarios, individual components, ingredients, or atoms come together to create a new entity with distinct properties, like a cake or a chemical compound, that is different from any of its individual parts. The upward force fluids exert, it keeps objects afloat. Buoyancy is the force that allows objects to float in liquids or gases. Imagine trying to hold a beach ball underwater in a swimming pool. It always seems to pop back up to the surface, no matter how hard you try. This is similar to how buoyancy works, where fluids exert an upward force on objects immersed in them, keeping them afloat. Just like the air inside the beach ball makes it want to rise to the surface against your efforts, buoyancy lifts objects in a fluid, with the water pushing back against the weight of the ball, analogous to how buoyant force counteracts the weight of an object in water. A measurement system based on units of 10, like meter or liter, is the metric system. The metric system is an international system of measurement used in science for its simplicity and consistency. Imagine trying to organize your closet, but finding it difficult because every item is a different shape and size, making it hard to stack or categorize them efficiently. The metric system is like deciding to use uniform-sized boxes for everything in your closet, making it easy to stack and organize because each box is a multiple of the same basic unit. Just as using consistent box sizes simplifies your closet organization by creating a standard structure, the metric system simplifies measurement by using units that are consistent multiples of 10, like meters or liters, allowing easy conversion and scalability. Measure of the force of gravity on an object. Weight. Weight is how much gravity pulls on an object. Imagine you're trying to carry a backpack filled with groceries up a flight of stairs. Just like how the backpack feels heavier depending on how many items you pack into it, the weight of an object is essentially how much the Earth's gravity is pulling it down. In both cases, the heaviness you feel is a direct result of an external force acting on the mass you're trying to lift. Whether it's the force of gravity on the groceries or the strain on your arms as you climb the stairs. How hot or cold something is, it is determined by the kinetic energy of its particles. Temperature. Temperature is a measure of how fast the particles in a substance are moving. Imagine you're at a party, and you notice how lively or dull it feels depends on how much people are moving around. Similarly, the temperature of an object is determined by how energetically its particles are moving. Just like a high-energy party feels warmer with people dancing and talking, an object is hotter when its particles are moving rapidly, while a cooler party, where people are standing still and quiet, mirrors the slow movement of particles in a colder object.